Okay, so good morning to all. Hi students, how are you all? I think all of you are very good and fine, and welcome to the session of permutations. And in this we are going to solve multiple choice questions, as well as we are going to see one of the synopsis of a circular permutation. Hello, is it audible? I think voice and screen both are very much clear, so that we can start our class as soon as possible. So tell all your friends to join the class. Yesterday we have done fundamental principle of counting. In that we have done fundamental principle of addition as well as multiplication. Next we have gone through one of the problem of 3-digit even number. So and we have solved it, no problem. Next we have gone through factorial notations. Next we have gone through some of the problem of factorial notation and properties of factorial notation also we have seen yesterday. And we have gone through permutation and formula of permutation with properties, and we have solved the fourth problem. Now we have to go for the fifth problem. Okay, so quickly tell all your friends to join the class so that we can start the class with problem number 5. Okay, so that is in the problem number 5 you can just see a very simple problem. I think all of you can solve it on your own because it is very simple, and it is from your NCERT textbook only. Okay, I think everyone can solve this, so try to solve on your own, and I will also solve it. Good morning. So good morning to all. Okay, you just see in the fifth problem what they have given. They have given that n minus 1 p3 is to n p4 is equal to 1:9. Okay, so here we can write it as n minus 1 p3 divided by n p4 is equal to 1/9. Clear? So from this you can use NPR formula. What is NPR formula? N factorial divided by n minus r factorial, right? So this implies n minus 1 factorial divided by n minus 1 minus 3, that is n minus 4 factorial. Okay, so you have n minus 1 and 3, so that you can write it as n minus 1 minus 3 factorial, that is nothing but n minus 4 factorial, and the complete term is divided by n factorial and you can see here it is n minus 4 factorial, and that will be equal to 1/9. Okay, so now you can just see n minus 1 factorial divided by n minus 4 factorial multiplied with n minus 4 factorial divided by n factorial equal to 1/9. So here you can easily watch that or easily observe that n minus 1 factorial and here n factorial. How can you write n factorial? N factorial can be written as n minus 1 factorial into n. So therefore cancel n minus 4, and you just see this is n minus 1 factorial divided by n minus 1 factorial into n equal to 1/9. Okay, I am writing here. So n minus 1 factorial will get cancelled. Therefore from this you can write n will be equal to 9. So very simple problem, and you can just see that it will be n equal to 9, and we have our option A as the correct answer. Okay, so who all not understood, you just see here they have given in the form of ratio. n minus 1 p3 divided by n p4. Here n minus 1 p3 means use npr formula. So if you use npr formula, it will be n minus 1 factorial divided by, you can just see n minus 1 minus 3. That can be written as n minus 1 minus 3, therefore n minus 4 factorial. So that will be n minus 4 factorial, and total term is divided by n factorial divided by n minus 4 factorial. You just simplify this by taking n minus 1 factorial divided by n minus 4 factorial multiplied with n minus 4 factorial divided by n factorial. Cancel n minus 4 factorial, and you are going to remain with n minus 1 factorial, here n factorial. Okay, n factorial can be written as n minus 1 factorial into n factorial. Cancel n minus 1 factorial, n minus 1 factorial, so that you are going to have n equal to 9. Okay, so we got n equal to 9. Clear? So quickly share the channel with everyone, so all your friends can attend the class. Most of them are not attending it. Okay, now we can go for problem number 6. Now we can go for problem number 6, that is, okay, first you read the problem very carefully. In how many of the distinct permutation, in how many of the distinct permutations of the letter in the Mississippi do 4 I's not come together? So they are asking 4 I's not come together. Okay, so we can calculate first 4 I's together. That means you just see the total number of the permutations. We have to find it with total number of permutations, total number of permutations minus 4 I's come together. 4 I's always come together. We have to subtract this, so that we will get 4 I's never come together. Okay, so that's why be careful. First we have to find total number of the permutations, and in that 4 I's always come together, we have to subtract. So that means we will get 4 I's never come together. This is your complementary law, complement set law. Okay, complement law. Okay, you have learned it in complement sets. Okay, so whenever you want to write complement set, how you write? U minus A, universal set minus set A. In the same way here, if you want to find 4 I's not come together, means in total number of the permutations, you just subtract 4 I's always come together. So here you can just clearly see you have 11 letters in the Mississippi. So 11 factorial divided by, in that S is repeating for 4 times, that is 4 factorial. I is repeating for 4 times, so you can write it as 4 factorial, and P is repeating for 2 times, so that you can write it as 2 factorial. Okay, this is total number of permutations. In that, what you have to calculate? 4 I's come together. That means you just see here, you have 4 letters. That means I will take 4 boxes, 3, 4, 5, 6, 7, 8, 9, 10 and 11. So you have total 11 number of boxes. Okay, because in the Mississippi you have 11 letters, so I will take 11 boxes, 11 different boxes. Okay, so now from this 11 different boxes, you just see now 4 boxes will remain always same. That means 4 boxes are going to be converted into the same box, that is 1 box. Clear? Now I will remove these 4 boxes and I convert them to only 1 box. Now I will convert them to only 1 box. Why? Because here all 4 I's are coming together. Here all 4 I's are coming together. So I has to convert these 4 boxes as 1 box. Okay. So now you just see the 4 boxes has converted to only single box. That means all I's will be present here. So this 4 I's will become only 1 I. Now how many boxes? You see 1, 2, 3, 4, 5, 6, 7, and this is 8th box. That means 8 factorial. Okay, in this S is repeating for 4 times. You can write 4 factorial. Now I can't write this as 4 different i's because they all are getting converted to only one. They are all, the 4 i's are becoming now only a single I because they are always kept together. They are always kept together here. So that's why now they are not called 4 different i's. They are called only one I because always they are in one box. Okay. So now I can't write them as 4 factorial. So P repeats for 2 times. I will write it as 2 factorial. Clear? So now you have to simplify this. You have to simplify and you have to get the answer. So I think everyone got the concept. If you have not understood the concept, you can just ask me. I will explain it again because here the concept is very, very important. So who all not understood the concept, you can ask again, no problem. So 11 factorial means 1 into 2 into 3 into 4, 5, 6 multiplied with 7, 8, 9, 10 and 11 divided by what? 4 factorial. 4 into 3 into 2 into 1. Again 4 factorial. 4 into 3 into 2 into 1. 2 factorial. 2 into 1. Okay. Minus 8 factorial. 8 into 7, 6, 5, 4, 3, 2, 1. This is known to everyone. Okay. 4 factorial. 4 into 3 into 2 into 1. 2 factorial. 1 into 2. Clear? Okay. So now you just see, I will cancel 4 factorial and 4 factorial. Clear? So I will remain with 4 into 2, 8. So 4 into 2, 8, 8 I will get cancel. 3 into 1, 3 into 2 I will cancel. Okay. So 2 into 1, 2 into 1 I will cancel. What is remaining term? Here you just see 5 is remaining. 5 into 7. 5 into 7 multiplied with 9, multiplied with 10 and multiplied with 11. Okay. Minus here again 4 factorial. 4 factorial you can cancel. 2 into 1, 2 into 4 you can get cancel. So this is first box and our second box is 4 into 7 into 6 into 5. 4 into 7 into 6 into 5. So we have to simplify this. Okay. So first you calculate this number. 5 into 7 is 35. So here you just see this is 35 and this is 90. 90 into 11 is 990. Okay. So 35 into 990 we have to simplify. So you simplify 35 into 990. 35 into 990 will be 34650. Okay. So this is 34650 minus 7 into 4, 28. 28 into 30. So 28 into 30 will be 840. So now you subtract it and you get the answer. That will be 34650 minus 840. So it will be 33810. So 33810 is your answer. Okay. So quickly tell me, all of you, quickly give me the thumbs if you have understood it. So therefore option B is going to be the right answer. Here option B is going to be the right answer. So how many of you have understood it? Quickly give me thumbs. If you have any doubts, you can ask, no problem. So quickly tell me. Very simple problem, very simple problem that you can understand it very easily. So quickly give me the thumbs. Okay. Then I can go for the next problem. Clear? Okay. So circular permutation I will come at last. Combination let us see later. So first we shall go for the another problem. You just see another problem, that is how many 5-digit telephone numbers can be constructed. How many 5-digit telephone numbers can be constructed using 0 to 9 if each number starts with 67. and no digit appears more than once. Okay, so my dear students, you can just see here, I have to construct how many digit telephone number? 5 digit telephone number. So this is 5 digit telephone number. Here you got 0 to 9. You got 0 to 9 means total 10 digits. You got total 10 digits 0 to 9. So here what they are telling, if each number starts with 6, 7. So these are fixed. Okay. 6 and 7 are fixed, so we can't do anything with this. Now they are telling no digits appear more than once. That means already 2 digits used here, already 2 digits used out of 10. So how much are remaining in this 10? Now we are remaining with only 8 digits, because we can't repeat the digits, that's why 2 are already used here and they are fixed there. So now we are only remaining with 8 digits. Okay, so in that 8 digits I will use here. For this box, how many choice you have? You have 8 choice. Okay, for this box, how many choice you will remain with? You will remain with 7 choice. For this box, how many choice you are having? 6, because see here, by using this 2 here, you are going to remain with 8 digits. So from this 8, you use 1 here. If I use 1, you will remain with 7 digits. Use 1 here, you will remain with 6 digits. So use 1 here. Okay. So that means you got 8 choice, 7 choice, 6 choice. Don't worry about this because they are fixed. So now your answer is going to be equal to 8 into 7 into 6. Okay. 6 into 7, 42, and 42 into 8, if you calculate, it will be 16. 8 into 4, 32. 32 plus 1 is 33. So 336. 336 is our correct answer. That is option A. 336 is our correct answer. That is option A. Okay. So quickly give me thumbs, all of you. If you are following, if you are understanding, if you are getting what I am explaining, quickly give me thumbs so that we can go for the next problem. So for the next problem, it is same as the first problem. So try to solve it and give me the answer. I will wait and see how many of you can give the answer. A very easy problem, very easy problem that everyone can solve it, I know. So that's why I will wait for you also, so that you can also solve one of the problem and you can also give me the correct answer. Okay, so I will wait for you also for problem number 2. Okay, so I will wait for problem number 2 from your side and I will see how many of you can give the right answer. Okay, already this is there in your NCERT textbook. It may be in your NCERT exercise also. This may be in your NCERT exercise also. Okay, so here you have 5 different flags. Okay, so you have 5 different flags like this. Clear? So now what I have to do, how many different signals can be generated if each signals require using 2 flags. So this is one signal where I have to use 2 flags. Okay, one below the other, where I have to use 2 flags, one below the other, if each signal requires 2 flags. Okay, so now you see, given 5 different flags, and if each signal requires 2 flags, how much you can do? Very good. Most of you are giving the right answer. You just see, I have 5 choice for first thing. I have 5 choice here. Okay. So for the first, I have 5 choice. And for the second, I have 4 choice. How many totally? 5 into 4, that will be 20. 5 into 4, that will be 20. Very good. So option B is the correct answer. All of you have given the correct answer. Very good. Keep it up so that quickly we can go for the next problem. Quickly we can go for the next problem. Okay. Okay. See, we have to make a committee. In the third problem, you can just see we have to make a committee of 8 persons. From a committee of 8 persons, in how many ways we can choose chairman and vice chairman, assuming one person cannot hold more than 2 positions. Okay, so see here, there are 8 people. There are 8 people like this. Okay, so now from this 8 people or from 8 persons who are different persons, okay, I has to choose 2 persons, one for chairman, one for chairman and another one for vice chairman. Okay, one for chairman and another one for vice chairman. Clear? So we have 8 different people. We have 8 different people. So from this 8 I can choose. For the chairman I have how many choice? 8 choice. For the vice chairman, because already one person is sitting on the position of chairman, so we are remaining with only 7 choice. So this has got 7 choice. Okay. So now for the chairman we have 1 position. So this chairman has got 8 ways. This chairman has got 8 ways for selection and this vice chairman has got 7 ways. Okay, so now you can just see 8 into 7, 56 ways are there to choose chairman and vice chairman. There are 56 different ways to choose chairman and vice chairman. Okay, so from this we can tell that 56 is the correct answer. 56 is the correct answer. Okay, very good. Clear? So most of you have given the right answer. Very nice. All are participating very interestedly. You also have to participate. Okay, no problem. I can go for problem number 4. Now I will see how many of you can answer for this. Now I will see how many of you can answer for this. So I will wait for 1 minute so that you can answer for it and you can give the right answer. Okay. So I will see how many of you can give the right answer for this. So let us wait and I will just see how many of you can give the right answer for this. 4th problem. So quickly go for it and simplify and try to give the right answers. So now here you have 1 by 6 factorial. 1 by 6 factorial divided by 1 by 7 factorial, x divided by 8 factorial. So till now I have not got any answer. Till now I have not got any answer. Rajan is telling 64. Okay. Anu Hanchate is also telling 64. Very good. Srinivas is telling 65. Let us see what will be the answer. Another person, Om Shri, is also telling 64. Very good. Most of you are telling 64. Okay, so let us see. So here 1 by 6 factorial, 7 factorial can be written as 1 by 6 factorial into 7 and 8 factorial can be written as how much? Here 6 factorial into 7 into 8. So now you can just see, I can take 1 by 6 factorial as common. So here I will remain with 1 plus 1 by 7. So here also you have 1 by 6 factorial into x divided by 7 into 8. So 1 by 6 factorial, 1 by 6 factorial will get cancelled. This will be 8 by 7 equal to x divided by 7 into 8. So here 7 and 7 will get cancelled and x will be equal to 8 into 8, that is 64. Okay. So 64 is the right answer. 64 is the right answer. That is option B. That is option B. Very good. Most of you have got the right answer. Option B, that is correct. Okay. Very good. All have done very nice work. They are preparing for the exams very nicely. So from this I can understand all of you are really doing nice work for your exam preparations. Do like this, and you can always, if you do all like this, you can always score good marks. Okay. So can I go for the fifth problem? Okay. Will you solve this or I have to solve this? Will you solve the fifth problem or I have to solve the fifth problem? Quickly tell me about the fifth problem. Okay. So the value of 2 to the power of n, 1 into 3 into 5, so on to 2n minus 3 into 2n minus 1 is, they are asking. So will you try this? So my opinion is you have to try once. You have to try once. All of you quickly in 1 minute. I will wait for 1 minute and I will see. Can anyone give the answer? Can anyone give the answer? That is 2 to the power of n into 1 into 3 into 5, so on to 2n minus 3 into 2n minus 1. Okay. Most of you are telling as C, because if one of you give the option as C, other will also follow him. C, C, C. But solve and tell the answer. Okay. Here I have 2 to the power of n, 1 into 3 into 5 into so on to 2n minus 3. This is 2n minus 1. So now what I will do, I will multiply it with 2 into 4 into 6 into 8 into so on to 2n. Okay. So divided by, again with the same term, that is 2 into 4 into 6 into 8 into so on to 2n. Okay. So now here you can just rearrange these terms as 2 to the power of n, 1 into, you have 2 here, no problem. You have 3, you have 4, you have 5, you have 6, so on to, you have 2n minus 3, 2n minus 1, you have 2n. Okay. Divided by, you just see, 2 can be written as 2 into 1. 4 can be written as 2 into 2. 6 can be written as 2 into 3. 8 can be written as 2 into 4. So on to 2n can be written as 2 into n. Okay. So here 2, 2, 2, 2, 2 is repeating for how many times? N times. So therefore you write this 2 to the power of n as it is, and this whole term can be written as 2n factorial divided by. So here 2 is repeating for n times, so you can write it as 2 to the power of n. And if I write 2 is repeating for n times 2 to the power of n, what are the remaining terms? 1, 2, 3, 4, so on to n. So that will be n factorial. Okay. So 2 raised to n, 2 raised to n will get cancelled. You will get with 2n factorial divided by n factorial. This is your answer, that is option A. So option A is the right answer. Option A is the right answer. Okay. So from this you can understand here option A is going to be the right answer. Quickly, if all of you are following, quickly all of you are understanding, quickly you tell me yes, so that I can go for the next problem. And no problem, if you get any doubts you can ask, I will explain it. So you just see, they have given this particular product 2 to the power of n multiplied with 1, 3, 5, so on to 2n minus 3 into 2n minus 1. Okay. So now from this what I will do, I will multiply and divide by this even multiplication, that is 2 into 4 into 6 into 8 into so on to 2 to the 2 into n, and divide by 2 into 4 into 6 into 8 into 2 to 2n. Okay. So after that you just see 1, 2, 3, 4, 5, 6, you have 7, 8, so on to 2n, 2n minus 1. So that will be 2n factorial. Okay, divided by, here 2 can be written as 2 into 1, 4 can be written as 2 into 2, 6 can be written as 2 into 3, 8 can be written as 2 into 4, 2n can be written as 2 into n. So from all this, take 2 outside, that means 2 is repeating for n times, that will be 2 to the power of n. 2 to the power of n, 2 to the power of n will get cancelled. You will remain with 2n factorial divided by n factorial. Okay. Now quickly we can go for the next problem, that is the exponent of 3 in 100 factorial is the exponent of 3 in 100 factorial. Okay, the exponent of 3 in 100 factorial. So I will see anyone can answer for this. So here if they have given like this, you must know one formula for this. You must know one formula for this, that is, here 100 can be written as the factors of prime you can write it as prime factorization as 2 to the power of a, 3 to the power of b, 5 to the power of c into 7 to the power of d, like this. Okay, this is called prime factors of 100 factorial. Prime factors of 100 factorial. You have 3 here. Okay, so you have 3, that is prime number, and you are finding 3 to the power of b, and you are finding specially b, that is exponent. Okay, so now we can solve it by e of 100. So that is nothing but greatest integer of 100 divided by 3 plus greatest integer of 100 divided by 3 square plus greatest integer of 100 divided by 3 cube plus greatest integer of 100 divided by 3 to the power of 4. Okay, so next I can't write greatest integer of 100 divided by 3 to the power of 5. I can't write that. It will be not according to our problem. Clear? So now you can just see here greatest integer of 33.3 plus greatest integer of 11 point something, you can take it as 1. Here you can write 27. 100 divided by 27 means 1.1 something. Here you have okay, this is 27. 100, if you simplify, this will be 27 into 3. Okay, so 3 point something. So now if you simplify this, it will be 1 point something. Clear? So clearly greatest integer of 33.3 is 33, 11.1 is 11, 3.1 is 3, 1.1 is 1. Okay, so this will be 44 plus 4, 48. 44 plus 44, it will be 48. Okay, so 48 will be our right answer, that is option B. Okay, so now from this I think all of you can understand. That we can get the answer with this one of the beautiful theorem of prime factorization, and all of you remember this because it is a very beautiful theorem as well as very beautiful trick. It can be very helpful for your exams. This type of problems actually we have to solve, but because of some terms and conditions we have to go for problems in your NCERT textbook. No worries, you can just go through it and you can understand. Okay, so quickly we have solved nearly 7 and plus to 9 problems. Now I will go for one of the important concept, that is circular permutation. Okay, so you just see what is circular permutation. Say if objects are arranged along closed curve then permutation is known as circular permutation. Okay, if the objects are arranged in the curve, okay, or in the circular shape, we call it as a circular permutation. In other words, the permutation in a row has a beginnings and end, but here in circular permutation there will be no beginning as well as there will be no end. Okay, so we need to consider one object is fixed and the remaining objects are arranged in n minus 1 number of factorial ways. Okay, you can just see here the arrangement of the objects, in the circular shape is called circular permutation, Okay, so now here there will be no beginning as well as no end. So what happens, you have to fix one object, and the remaining objects you have to arrange them in circle, circular shape. So if you have n objects, what happens, one object is going to be fixed here, that means the remaining n minus 1 factorials are going to be arranged. That is going to be nothing but n minus 1 factorial ways. So the circular permutation is given by n minus 1 factorial ways. I think everyone got this concept. Now we can go for one of the example which I have taken here. Consider there are 5 persons A, B, C, D and E to be seated in a circumference of a circular table, in order which has no head. Okay, now shifting A, B, C, D, E one position in anti-clockwise direction, we will get arrangements as follows. Okay, so now you see here that only I am taking one example here. I have 5 people. You just see, I have 5 persons named A, B, C, D, E. I have 5 persons A, B, C, D, E. Now what I want to do, I want to make them to sit in a circular table, in the circular shape, so that now what happens, you just see, you have 5 person means one person has to be fixed. Okay, so the remaining people, that will be 4 minus 1 factorial. 5 minus 1 factorial. That will be 5 minus 1 factorial. That means 4 factorial ways. There are 4 factorial ways to make these people or these persons to sit. Okay, so I think this example can give you a very clear idea that there are 5 persons. I want to make them to sit in a circular shape for a one table. So there is one table. Okay, you just consider there is one table like this in a circular shape. Clear? So now I want to make sit these 5 persons around this table. Okay, so you have 4 here, I have 5th person. So take this is A, B, C, D and E. Clear? So now if I want to make to sit these 5 people around this table, in how many ways I can make them to sit? What I have to do, I have to fix this person A. I will fix this person A and I will start to arranging. All the remaining things. This position is fixed. That means you remain with 4 positions. So what is our formula? N minus 1 factorial. So that means 5 minus 1 factorial. That will be 4 factorial. So 4 factorial is going to be the answer. Okay. So just you can just see here, I have taken those things. I have some arrangements here. These are anti-clockwise. These are anti-clockwise. Okay. These are anti-clockwise. On the same way, you can also arrange them in clockwise. On the same way, you can arrange them in clockwise. Clear? So clearly, I have given those particular anti-clockwise arrangements that you can just see. This is one example so that all of you can understand it. Now you just see the number of circular permutations is given by n minus 1 factorial, that can be written as npn divided by n. This is nothing but n minus 1 factorial. Everyone can simplify this, no problem. Okay, npn divided by n. Okay, so that will be n minus 1 factorial. Clear? So now by this we can clearly go for combination concept. Clearly we can go for combination concept, and I will just go through the definition of combination. I will just go through the definition of combination, and already you know what is permutation. So can anyone give me the definition of permutation in the comment box? So quickly write me what is the definition of combination, sorry, permutation. In the comment box, quickly type the definition of permutation. Quickly type the definition of permutation in the comment box. So I am expecting your answers so that you can write the definition of permutation in the comment box. We have gone through different types of problems, as well as I have gone through the permutation definition as well as NPR formula. So now I want the definition of permutation in your comment box. Quickly write it. Okay. So permutation means arrangements. If you write that much, more than enough. Very good. Very good, Sajjan. Permutation means arrangements. If you write that much, it is more than enough. I can understand it. Okay. Permutations means it is an arrangement. So there will be n different type of objects. Out of them, I have to select R. So I have to arrange that R objects. Okay. So that is called permutation. Permutations is nothing but arrangements. Permutations is nothing but arrangements. So what type of arrangements? NPR, number of ways. So the ways of the arrangements are NPR. Okay, NPR is nothing but n factorial divided by n minus r factorial. N factorial divided by n minus r factorial. Okay, so why I have asked this means, now I am going for combination. Now I am going for combination, so that in combination what we do, we just select. We are not bothered about the arrangements. Please remember, we are not worried about the arrangements in combination. We are not bothered about the arrangements in the combination. We are just going to select them. We are just going to select them. That's all. Okay. So permutation is arrangement, combination is selection. Clear? Each different groups or selections. You can just see. Here I am going to select R elements out of n objects. This is selections which can be made by sum of n objects or taking all the n objects together. Okay. Given things without reference to the order. Without reference to the order. You can just see here, I am not referring to any type of order. Clear? So each group is called combination. Each group is called combination. Okay. So now you just see, if I take A, B, C as three objects, then what are the ways? Then what are the ways? What are the ways of selection? What are the ways of selections? Please tell me the answer. On the same way, quickly you can observe the same example for permutation also. Yesterday we have solved this. See what here they say, the arrangements of the two objects. The arrangements of the two objects from three objects they tell. Okay. So now what we are doing here, we are taking just two objects. That means the ABC objects. Then what are the ways of selections of two objects? Of two objects. Can you tell me? Can you tell me what is answer for this? Quickly, everyone. Quickly, everyone, tell me answer for this. Okay. So I'm waiting for your answer. I have two objects, so I have to select two objects. Just in the comment box you write what are the ways. What are the ways of selecting two objects? Of selecting two objects. Okay. Okay. So quickly tell me. So Sneha is telling that AB, BC, AC, AA, BB, CC. Very good. Very good. Clear? So now I can take AB. I can take AC. Very good. I can take BC. And what about others? You can take AA. You can take BB, you can take CC, like this. Clear? So here, if I do this, what happens? This is repetition. Okay, this is repetition. Clear? So what I am telling? Two objects. I am telling two objects means two different objects. Okay, not same objects. Two different objects. Clear? So I can't repeat this. Once if I take A, it is over. If I once select A, it is over. Okay. If I once select B, it is over. If I once select C, it is over. That means these things are not allowed. These things are not allowed. Okay. So please be careful. Please be careful. Clear? Because you can just see you have AB, AC, BC. You can't do more than this. Clear? Only you have three number of ways. Three number of ways. Clear? So therefore, if I select A once, see my dear students, that is what the difference between permutation and combination. Please understand here. That is what the difference between permutation and combination. Combination means selection. Combination means selection. So out of these three, if I select A once, my work is over. I can't select A again. If you select A again, see here what happens. If you select A again, this is called arrangement. This is called arrangement. This is not called selection. This is not called selection. Okay. Here selection means if you once you take that is over. If you once take it, that is over. Okay. If you take AA means that is selection. Sorry, that is arrangement. If you take BB means that is arrangement. If you take CC means that is arrangement. Okay. So that's why only possible cases are AB, AC, BC. Clear? And clearly we write it with one formula, that is NCR. So that will be n factorial divided by r factorial, n minus r factorial. Okay. So you can go through it and you can check it. You will get the right answer. No problem. Now we can quickly move to the difference of permutation and combination. So quickly tell me what is the difference between permutation and combination. What is the difference between permutation and combination? Very good. Combination is selection, permutation is arrangement. Combination is selection, permutation is arrangement. Okay, very nice. We can't rewrite the choices. We can't rewrite the choices. Please understand, we can't rewrite the choices. Why we can't rewrite the choices? Because you just see why we can't rewrite the choices, because only one reason. This is selection. If we rewrite the choices, that will be the arrangements. That will be the arrangements. First, you clearly understand what is the difference between arrangements and choices. What is the difference between arrangements and the choices? Okay. So now we can just see that. Arrangements we can write again and again by rearranging. But while doing selection, if I once select AB, the BA is also called as the same selection. For example, see here, for example, I have 5 persons, or I have 5 students. And I has to select 2 people or 2 students. I has to select 2 students. Okay, take this is person P, A, V, A. Okay, there are 4 people, or you can take this as 5th one also, no problem. Okay, complete this. So you have 5 people with name P, with name A, with name V, with name A, and with name N. So here A is repeating. That means these 2 are the same. These 2 are the same person or the same student. These 2 are the same students. Are you getting my point? So I can't repeat that. Clear? So that's why, see here. So from if you get confused, let us remove this. I will take 4 different names, A, B, C, D, E. I will take 4 different names by A, B, C, D. Take A, B, C, and D. Now I want to select 2 students. If I select B and if I select D, this is one selection, B, D. Okay. So see here, if you say D, B, this is nothing but the same selection. Here also there are same students. Here also there are same students. It doesn't mean that they are different students. Okay, this is not arrangement. This is selection. In this team also there are same students. In this team also there are same students. So that's why I can't do the 2 teams with the same members. I has to select different teams. Have you understood? Okay. I think all of you can understand this. If I do these 2 teams, everyone will arise a question, sir, these 2 teams are same. They are not different. These 2 teams are same. They are not different. All of you tell. And all of you start to argue. Okay. So here combination means selection, not arrangement. Combination means selection, not arrangement. Clear? So I think everyone have understood this. So quickly give me thumbs, all of you. So in the next class, we can start solving the problems on combination. And we can also see the properties and the formulas of combination, and properties of the combination formula, that is NCR. And we can just see how the formulas of NPR and NCR are going to relate each other. All of you, are you enjoying the classes? And soon I am coming up with foundation course. As I said, I was taking foundation course for you people. So again I will come up with foundation course of our first chapter, that is relations and functions, and our second chapter differentiation, and so on. It goes for application of differentiation, integration, application of integration. That is your second year syllabus. So soon I will start the foundation course for your second year syllabus. So my dear students,
Already you all are in second year, so please be careful. We have to start as soon as possible our foundation course. So I will set the time, I will schedule the timetable, and I will give timetable for all of you, so that according to that I will take the classes, and everyone should present in that class. Everyone should be present in that class. Okay, so thank you everyone. We shall meet in the next session. We shall meet in the next session. Okay, take care and bye. Clear? Take care and bye. Okay.